Hello, so let's look at this question. If a and b are integers such that 2x square minus ax plus 2 is greater than 0 and x square minus bx plus 8 is greater than equal to 0 for all x, okay, for all real x, for all real x, then the largest possible value of 2a minus 6b is, okay. So any equation, if for all x remains positive, not even 0, positive, the first thing that should pop into your head is this graph looks like something like this. And when this graph looks something like this, then d is less than 0, because these are imaginary solutions. So d should be less than 0. Now d is b square minus 4ac in a standard equation of x square plus bx plus c equal to 0, right? So in this equation, if we look at, b is a minus a, which becomes a square minus 4 times a is 2 and c is 2. So this becomes a square minus 4 into 4 is 16, which should be less than equal to 0 as d is less than 0 from 1. So a square should be less than 16. That finally means that any integer value, because a and b are integers such that their squares are less than 16, that means a can take value plus 3, plus 2, plus 1, 0, minus 1, minus 2 and minus 3. It cannot take 4 because it will turn into an equality, hence we cannot go beyond this range for a. Similarly, if we solve this, now there is an equality included, right? But it is not negative. So if for all x this has to be greater than equal to 0, the function, the graph should look something like this, and for this they should be equal to 0. Fair enough? They should be equal to 0 for real roots but equal roots. So for this equation, again we come from b square minus 4ac. So this is d. So b is b here, actual minus b whole square is b minus 4 into 8. Because a is 1, so it directly becomes 4 into 8, it becomes 32 and b square is 32. Now there are two conditions here. D can either be 0 or D can be positive, because there is an inequality here as well. So instead of writing two equations, for one for this and one for this, I basically write this as D greater than equal to 0. That means B square is greater than equal to 32. Fair enough? When I say that B square is greater than equal to 32, B's values that B can take, because B is an integer, basically means the closest to this is I think 25, which is 5 square, right? More than that, let's see, can we go? 6 square is 36. So yeah, all the values that B can take is plus 5, plus 4, plus 3, plus 2, plus 1, 0, minus 1, minus 2, minus 3, minus 4 and minus 5. Right? We got the range. Now the function that we need to calculate is 2a minus 6b and its largest possible value. So we have to maximize this function. Any function in which there is a difference, the term from which something is subtracted has to be maximized, and something that is subtracted is to be minimized to maximize the whole. Hence a's value should be as high as possible and b should be as low as possible. So a as high as possible is 3, hence 2 into 3 minus 6 into b as low as possible is minus 5, hence we go minus 5. So this becomes 6 plus 30, which gives us finally 36. The answer to this question is 36. Okay, this is one way to solve this. There is another longer way to do this with doing factorization or perfect square method. So basically what we do is we create perfect square formulation for this equation, let's say equation number 1 and equation number 2, and then we figure out the minimum values from there, it will give the same answer, but it is way longer and it takes a lot more brain power than doing this method. So I think I prefer this method. I hope you also will prefer this method, and I'll see you in the next one. Happy preparations.